Alright, so we're doing 8-8, which is linear and quadratic functions. This is going to be the last section we're going to be doing in chapter 8. Okay, awesome. So let's figure out the difference between a linear function and a quadratic function. Okay, a linear function is a function f defined by f of x equals mx plus b. And so, again, it's not always going to be f. It could be g of x, h of y, whatever the case is. But keep in mind, f of x is the same as your y, okay? So then you're familiar with this. Y equals mx plus b, right? Linear equation. That's in slope-intercept form, but it's a linear equation. If you graph it, it will be a line. So f of x is just representing y, okay? But it's a function. Not all graphs are functions. Not all lines are functions. And again, we talked about this before, but this is basically saying it's whatever you plug in for x goes in here, and then you can find what f of x is by solving. Now, if the domain of f is the set of real numbers, then its graph is a straight line with a slope m and y-intercept b. Standard, we've learned that. There we go. Now, a quadratic function. A quadratic function is a function f defined by and I'm going to rewrite it over here, f of x equals ax squared plus bx plus c, and I'm putting in parentheses, a cannot equal 0. I just have to do that for standard measures because if a equals 0, then this whole thing would be canceled out, and then it would be a linear equation because it would look like a linear equation. So you have to have a being something other than 0 for it to be quadratic. But you'll just need to really focus on this. Again, this can be considered your y, and then you have your x's. A, b, and c are all just numbers, okay? So it could be like, 5x squared plus 2x plus 3, okay? They're numbers. Now, if the domain of f is the set of real numbers, then its graph is a parabola. So it's not a line, it's a parabola. Parabolas look like this. Ooh, I don't know what happened. Okay, looks like this. That's a parabola, okay? Kind of like a U shape. Now, if a is positive, then the parabola opens up. So it's going to look something like this one right here, opens up. That means it has a positive a. Now, if a is negative, hopefully you figured out, then that means it's going to open down. It's going to look like that over there if it's negative. Pretty simple. The x-coordinate of the vertex of the parabola, which we just stated, is going to be found by doing negative b over 2a. Okay? So you're going to use your b, you're going to use your a, and it's going to help you find the x-coordinate for your vertex. What is the vertex? The vertex is the tip top of the parabola, or the very bottom. It's the highest or lowest point. That is your vertex, and that vertex will have a set of coordinates, okay? And negative b over 2a helps you find the x-coordinate. And if you know one of the coordinates, you can find the other coordinate. Now, the axis of symmetry, we know symmetry is where it's the same thing on either side, it's reflecting. The axis of symmetry is a line, so a line has to be an equation. The equation is x equals negative b over 2a. You need to have x equals to make it a line. We know that x equals equations are vertical lines, so it's a vertical line. And that should make sense because if I were to draw an axis of symmetry over here, right? I'm doing dotted line for the axis of symmetry. It's a vertical line, up and down. Okay, so we're going to keep that in mind as we are going to graph and find different features of a quadratic function. So it says graph the function k defined by the equation y equals or k of x. See, it's the same thing. They're the same thing, so you can look at one or the other. Negative x squared plus 2x plus 2. Well, a, if you look here, a is technically negative 1. If it's negative, we know it's going to be we always know it's going to be a parabola because it's in that form ax squared plus bx plus c. It's a parabola, and it's going down, right? Okay, so now we're going to graph it, and we're going to find the coordinates of the vertex, the greatest or least value, and the axis of symmetry, and I'm going to show you how to do that. First off, I'm going to just find some coordinates. Okay, I like to stick with the standard -2, -1, 0, 1, 2 to kind of get a range of values. So I'm going to rewrite my equation. I'm going to rewrite it. It's k of x equals negative x squared plus 2x plus 2. And basically, if I plug in -2 for x, okay, I need to find out what my y is. Okay, so I'm going to write out the first one, how to plug it in, but I'm not going to do it for every single one. So I have a negative 2x squared, okay? Don't cancel out the negatives, not yet. Plus 2 times -2 plus 2. So all I did, in parentheses, instead of wrote x, I wrote -2, which I made my x. Order of operations says that we have to square the -2 first. -2 times -2 is a positive 2, but now it's going to be negative because of this negative right here. And then 2 times -2 is a -4 plus 2. So that's going to give me an answer of, so -2 minus 4, that's -6 plus 2, which gives me -4. Okay, so my first coordinate is -2, -4, and I'll plot that in just a second. I'm going to do the same thing by plugging it in for all of those, but I'm not going to show that work every time. So I'm going to say -1 squared is, I might have to have a little work. -1 squared is 1, but you have to make it negative, so we're going to have -1, and then 2 times -1 is -2 plus 2, so that's going to equal -1. 0, well, 0 squared is 0. 2 times 0 is 0 plus 2, so that's going to be 2. 1 squared is 1 minus, make it a negative, so it's -1. 2 times 1 is plus 2 plus 2, so that's going to give me 3. Okay, now 2 squared is 4. Make it negative, so that's going to be a -4. 2 times a positive 2 is 4 plus 2, so that's going to give me 2. I'm now going to graph my points. My points are -2, -4, so -2, -4, -1, -1. 0, 2, 1, 3, and 2, 2. If you notice, it's not quite looking like a parabola yet. It kind of like has this, like, again, I'm going to draw a line. It kind of goes like, trying to make it, and it rounds, but then it goes like this. Well, for me, knowing if I kept going and figured out 3 and 4, I would get this and this point. And that would complete my parabola, which makes sense because they have an axis of symmetry. And just by looking at this, I can figure out that my axis of symmetry is right here, which would be x equals 1. Okay, just by looking at that. So it says find the coordinates of the vertex. Well, that's the vertex. So my coordinates of the vertex, all right, vertex, are 1, 3. My axis of symmetry, AOS, is x equals, make sure it's an x equals 1, and my greatest or least value. It's saying that what is either the highest or lowest y that you possibly can have? Well, if you look, since this is going down, that means it's going to negative infinity. I'm not going to put that because it's negative infinity. It doesn't, like, it just keeps going on forever and ever. But, so it doesn't have a least value. It has a greatest value. And its greatest value is 3. It's not going to go higher than 3. So my greatest value, GV, is going to be 3. You're either going to have a greatest value or you're going to have a least value. So we got our information, we graphed it, there we go. Now we figured out these based off of graphing it first. I'm going to show you how to do it based off of not graphing it first, and that's going to make your life so much easier. Okay? So we have this one. Alright, so we're going to graph it, and it has a positive a, so we know that it's going to be going up. It's a parabola. Okay, so now we're going to find the coordinates of the vertex, the greatest or least value, and the axis of symmetry. I'm going to find those first before I graph it. I'm going to come back up here and look. I know that the x-coordinate of my vertex is negative b over 2a, and my axis of symmetry is x equals negative b over 2a. So I'm first going to find what negative b over 2a is. Well, my b is 4, my a is 2. So I'm going to say negative 4 over 2 times 2, which equals negative 4 over 4, which is negative 1. So I know that my AOS is x equals negative 1. I also know that my vertex's x-coordinate is 1. And I can easily find my y-coordinate by plugging it in for x. So if I plug in 1 for x, I get 1 squared times 2, which is 2, plus 1 times 1, or 1 times 4, which is 4, minus 3, so that's 6 minus 3, which is 3. I think I have the same vertex. Look at that. Oh wait, so sorry, it's going to be negative 1. Oops. Take that back. That only changes this right here. So that's 2 minus 4, negative 2 minus 3, that's me negative 5. My bad. Hopefully you caught that. So now that I have this, I can also find I'm going to have a greatest value or a least value. Well, if it's a parabola that's going up, I'm going to have a least value. You should know that because, again, it's where your vertex is. So my least value is going to be my y-coordinate of my vertex. So my least value negative 5. So now I'm going to plot what I have. I have my vertex, which is negative 1, negative 5. I have my axis of symmetry, which is x equals negative 1. And I'm also going to graph my points. I'm going to do 2 points to the right of the axis of symmetry and 2 to the left. They should mirror each other exactly. So I have x and y. So I'm going to do negative 3. Oh my goodness. If you saw that, congratulations. Does nothing for you. Okay. And so we do negative 3, negative 2, negative 1, 0, and 1. Those are the only points we need to find. We already know the coordinates for the vertex, which is negative 5. And let me rewrite my equation, which is 2x squared plus 4x minus 3. And so now I'm going to plug in for negative 3. Negative 3 squared is 9 times 2 is 18 plus a negative 12 minus 3. So that's going to be 6 minus 3, which is 3. Negative 2 squared, that's 4. 8 minus 8 minus 3, which would be negative 3. Then we have 0, which would be 0 plus 0 minus 3. And then 1, which would be 2 plus 4 minus 3, which is 6 minus 3, which is 3, which look, it mirrors it, which is what we thought. And